Hello everyone. So in this chapter of elastic constant, we see the concept of volumetric strain. Okay. So we start. We have already discussed that whenever a body is subjected to a single force or a system of forces, it undergoes some changes in dimension. A little consideration will show that the change in dimensions of a body will cause some changes in its volume. The ratio of change in volume to the original volume is known as volumetric strain. So what is volumetric strain? The ratio of change in volume to the original volume is known as volumetric strain. Okay. So mathematical formula for this is epsilon V is equal to delta V upon V. Delta V is equal to change in volume and V is equal to original volume. Though there are numerous ways in which a force or system of forces may act, yet the following are important from the subject point of view. So here you will only see the rectangular body subjected to an axial force. So we'll see that. Okay. So next derivation, volumetric strain of a rectangular body subjected to an axial force. So this is the rectangular body, and this is the forces which are subjected to which are acting on axial direction. This is the breadth, this is the length, this is the thickness. So consider a bar rectangular in section subjected to an axial forces. So let L is equal to length of the bar, sorry, length of the bar, B is equal to breadth of the bar, T is equal to thickness of the bar, P is equal to tensile force acting on the bar, T is equal to thickness of the bar, P is equal to tensile force acting on the bar, E is equal to modulus of elasticity, 1 upon M is equal to Poisson's ratio. Now we know that the change in the length delta L is equal to PL upon A. So we know this formula is equal to PL upon BTE because A is equal to BT. Because change in length, we are seeing the change in the length. So other two dimensions product is the area. So and linear stress is equal to sigma is equal to force upon area. Stress force upon area is equal to force P upon A. So A is converted into B into T. Now next linear strain. Linear strain is equal to stress upon capital E is equal to P upon BTE. Okay, P. So here stress is P upon BT into E. Now and lateral strain is equal to 1 upon M into linear strain is equal to 1 upon M into P upon BTE, that is linear strain. Therefore change in thickness is equal to delta T is equal to T into 1 upon M into P upon BTE is equal to P upon MBE. T gets cancelled. So P upon MBE. Now change in breadth. Delta B is equal to B into 1 upon M into P upon BTE is equal to P upon MTE. Okay. As a result of this tensile force, let the final length is equal to L plus delta L because of the deformation or change elongation L plus delta L. Final breadth B minus delta B because breadth will decrease. Thickness also will decrease. So final thickness T is minus delta T. Therefore minus due to compression. Okay? There will be compression. We know that the original length, original volume of the body is equal to V is equal to L into B into T, and final volume is equal to length plus delta L B minus delta B T minus delta T is equal to L into B into T in bracket L plus delta L upon L in bracket L minus delta B upon B. Then sorry, 1 plus delta L upon L, 1 minus delta B upon B, 1 minus delta T upon T is equal to LBT into bracket 1 plus delta L upon L minus delta B upon B minus delta T upon T minus delta L upon L into delta B upon B bracket complete minus delta L upon L into delta T upon T bracket complete plus delta B upon B into delta T upon T bracket complete plus delta L upon L into delta B upon B into delta T upon T bracket complete whole bracket complete is equal to that whole will be converted into LBT into bracket 1 plus delta L upon L minus delta B upon B minus delta T upon T. Now change in volume is equal to delta V is equal to final volume minus original volume. So it will be equal to LBT in bracket 1 plus delta L upon L minus delta B upon B minus delta T upon T minus LBT is equal to LBT in bracket delta L upon L minus delta B upon B minus delta T upon T. Okay. So next is equal to that will be converted into LBT in bracket T L upon BTE upon T minus P upon MTE upon B minus P upon MBE upon T. That will be getting converted into that will be LBT into P upon MBE P upon BTE minus P upon MBTE minus P upon MBTE. So that will be equal to P is V into P upon BTE in bracket 1 minus 2 upon M. M. And volumetric strain, that is delta V upon V is equal to, so an volumetric strain is equal to delta V upon V is equal to V into P upon BTE in bracket 1 minus 2 upon M upon V is equal to P upon BTE in bracket 1 minus 2 upon M is equal to epsilon 1 minus 2 upon M. So P upon BTE is epsilon, that is strain. Okay. So now we'll see the problem related to it. Okay. So problem 1. A steel bar 2 meter long, 20 mm wide and 50 mm thick is subjected to a tensile load of 30 kN. Find the increase in volume if Poisson's ratio is 0.25 and Young's modulus is 200 GPa. So we'll see, we have to solve the increase in volume, that is delta V. So from the given data is length L is equal to 2 meter, that is 2 into 10 raised to 3 mm, width B is equal to 20 mm, thickness T is equal to 15 mm, tensile load P is equal to 30 kilonewton is equal to 30 into 10 raised to 3 Newton. Poisson's ratio 1 upon M is equal to 0.25 or M is equal to 4, that is inverse of Poisson's ratio. Then Young's modulus of elasticity E equal to 200 GPa is equal to 200 into 10 raised to 3 Newton per mm square. Then let delta V is equal to increase in volume of the bar. We know that the original volume of the bar V is equal to LBT is equal to 2 into 10 raised to 3 into 20 into 15. That is from the formula is equal to this product will be 600 into 10 raised to 3 mm cube. And delta V upon V is equal to P upon BTE into bracket 1 minus 2 upon M bracket complete is equal to, now P is equal to 30 into 10 raised to 3 upon BTE, that is 20 into 15 into 200 into 10 raised to 3 into bracket 1 minus 2 upon 4 is equal to 0.00025. So delta V upon V is equal to 0.00025. Delta V is equal to 0.00025 into V is equal to 0.00025 into 600 into 10 raised to 3 is equal to 150 mm cube. So increase in volume, that is delta V is equal to 150 mm cube. So this was about the volumetric strain. Thank you.